Welcome to Study with Flow. In today's video, we are going to learn about polynomial regression. Now, what exactly is this polynomial regression? In statistics, polynomial regression is a form of regression analysis in which the relationship between the independent variable x and the dependent variable y is modeled as an nth degree polynomial. So over here, the power of x would be greater than 1. It can be 2, 3, 4, and so on and so forth. A polynomial regression fits a non-linear relationship between the value of x and the corresponding conditional mean of y denoted by e of y given x. So over here, we are primarily fitting a non-linear model. Although polynomial regression fits a nonlinear model to the data as a statistical estimation problem, it is linear in sense. Why is it linear in sense? Because our regression function e of y given x is linear in unknown parameters. That is, our slope and our intercept are going to be linear. Now, let us begin by modeling polynomial regression by first importing the necessary libraries. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import seaborn as sns, import warnings dot filter warnings. We are going to ignore these warnings. Now let us run these codes. Now, the next part is importing the data set. Let's do that. df is equals to pd dot read underscore csv. Now, let us look at the head of our data set, df dot head. So, over here, we have position, we have level, and salary. So, the level of an employee determines the salary that he or she receives. So over here, our independent variable is level and our dependent variable is salary, which is dependent on level. So before we begin with polynomial regression modeling, we have to divide our data into x and y. So our x is nothing but x is equal to df dot ilog. I want all the rows. I want only the first column. I do not want the last column. So the last column has an index of -1. And I need a NumPy array, so I will write dot values. Similarly, I can do for y. Y is equals to df dot ilog. I need all the rows, but I only need the last column. Dot values. Now, the steps involved in a simple linear regression and a polynomial regression are exactly the same. So now we first divide our data set into train and test. From sklearn dot model underscore selection, import train underscore test underscore split, xtrain xtest, bytrain bytest is equals to train underscore test underscore split. So x comma y, we will give a test size of 20%. So 20% of our data goes for testing and 80% goes for training. And random underscore state is equals to 0. This is not an important criteria. I'm keeping it as 0 so that my values and your values are going to be the same. Now let us run this code. Now, let us create our linear regression model. First, we'll understand why this linear regression model is not correctly predicting this data. So, from sklearn dot linear underscore model import linear regression. This is the first step. That is, we are importing the package. The next step is to create an object. Linreg is equals to linear regression. So next time when we want to use linear regression, we do not have to write the entire term. We can just write linreg. Next is fitting the model. We are going to fit the model onto our X train and Y train. Linreg dot fit X train Y train. And finally, the fourth step is to predict. Ypred is equals to linreg dot predict. We are going to predict using the X test. Now, let us run this code. Now, we have to check for the accuracy of the model, because without checking for the accuracy, we cannot say whether this model is a good model or a bad model. So, from sklearn.metrics import r2 underscore score, print r2 underscore score by test by print. Now let us run this. Now the R2 score over here is very low, that is 20%, which means that 20% of the variation in our independent dependent variable is because of our independent variable. This is a very low score. So our model is not able to predict properly the future outcomes. Hence, we have to look for some other way to resolve this issue. So let us go and apply polynomial regression on this data. Now, let us look at this plot to see whether our actual values and predicted values lie together. So PLT dot scatter x comma y comma, I will give a color as red. You can give any color that you like. PLT dot plot x comma linreg dot predict x, and I'm going to give this a color blue. Now let us run this code and see how the graph we obtain. So it's clearly visible that our line is not predicting all the points correctly. So the difference between the actual values, that is your red points, and the blue line is pretty high. So our linear regression model is not doing justice to this data. Now let us go on to apply our polynomial regression. How do we do that? From sklearn dot preprocessing import polynomial features. Now let us create an object for polynomial regression. Polyreg is equals to polynomial features. Degree is equals to 4. So you can mention the degree that you like. You can have a second order, second degree, third degree, fourth degree, and so on and so forth. Now we'll call x poly because we are going to apply this polynomial features onto our x. So polyreg dot fit. We are going to fit it on fit transform, fit underscore transform. We are going to transform x. Now let's create another instance of linear regression. Linreg1 is equals to linear regression. Now it's the time to fit. Now we will use the X poly to fit our data. And remember, we are again interested in finding the linear regression because over here our slope and our intercept continues to be linear in nature. Linear dot fit X poly and Y. The last is to predict. Y pred poly is equals to linrec dot predict polyrec dot fit underscore transform. Are we transforming the X variable? So now our polynomial regression is in place. We are still using a linear regression because our slope and intercept continues to be linear in nature. Now let us run this. What do we? Now it is our time to look at the graph to check if our polynomial regression is working or not. So how do we do that? PLT dot scatter, because we are making a scatter plot of x comma y and color is equals to red. PLT dot plot x comma y pred poly comma color is equals to blue. Now let us run this and then we are going to get our graph. So we get a nice looking graph over here. So we initially had a curve and now the curve that we have plotted covers all our red points. So we have successfully been able to predict the future outcomes. But there is a problem with this. This model cannot be generalized. What happens in the future cannot be generalized because over here it has tried to fit in all the data points. It has learned from the noise when it had to learn from the signal. So over here it is overfitting the data. We may get a high accuracy in training, but we'll get a very low accuracy when testing the data. Hence, the problem with polynomial regression is that it overfits the data, it overgeneralizes, and we cannot make future predictions using the polynomial regression. I hope the idea of polynomial regression and why polynomial regression is used and why we are fitting a linear model in polynomial regression is clear for